Good morning, my dear students. Today we are going to start a new chapter. The name of the chapter is Atoms and Molecules. In this chapter, we are going to study the basis of chemistry. Okay, so you should learn it thoroughly. Then, we have already learned about matter and its classification based on its physical as well as chemical properties, isn't it? What is matter? Anything that has mass and have volume. That is called matter, right? The ancient scientists were always wondering about the unknown and unseen form of matter. When we divide the matter again and again, a stage is reached where we cannot divide it any further, isn't it? Then, an Indian philosopher, Maharishi Kanad, called this indivisible particle that we get after dividing the matter called Paramanu. Okay, so the smallest particle that obtained after dividing the matter, the Maharishi Kanad called it Paramanu. Okay, then another Indian philosopher said that these small particles normally exist in combined form, which gives us various forms of matter. Okay, he said the reverse of it. These small particles will combine and we will get matter. Okay, then around the same era, ancient Greek philosophers named Democritus and Leucippus suggested that if we go on dividing matter, a stage will come when particles obtained cannot be divided further. Okay, that is when we divide the matter into smaller and smaller and smaller particles, the last small particles we obtained, we cannot divide it any further. And Democritus called these indivisible particles atoms. Okay, the meaning of the word atom is indivisible. That is, we cannot divide it any further. Okay, all this was based on philosophical consideration and not much experimental work to validate these ideas could be done till the 18th century. By the end of 18th century, scientists recognized the difference between elements and compounds and naturally become interested in finding out how why elements combine and what happens when they combine. Okay, so this is how the concept of atoms arises. Okay, so we already learned that the matter, it can be classified into pure substance and mixtures, and in the pure substance it can be again classified into elements and compounds. Okay, so let's recall the idea of elements and compounds. Okay, elements, it is made up of only a single kind of particles. Okay, that is element. It is made up of same kind of particles. Examples are oxygen, then gold. All these are examples of element. It only contains one kind of particle. Then compound, it is made up of more than different elements. Okay, compound, it is made up of different elements and they are combined in a fixed ratio. That is called compound. Example, water, hydrochloric acid, sodium chloride. All these are examples of compound, isn't it? So today we are going to learn about the laws of chemical combination. Before going to study the laws of chemical combination, firstly let's see what does mean by a chemical reaction. Okay, what does mean by chemical reaction?
In a chemical reaction, substance react to form new products. Okay, or in a chemical reaction, the substance react to form new substance. Here, chemical change is occurring. Such a reaction is called chemical reaction. For example, hydrogen and oxygen combine to form water. Here, a chemical change is occurring and this hydrogen and oxygen They are called the reactants. And the new product or the new substance that we obtain, it is called products. So, in a chemical reaction, the reactants combine to form new product. Such a reaction is called a chemical reaction.
Chemistry is the study of the change of matter from one form to another. These changes often occur as a result of the combination of two different types of matter. There are certain rules that govern the combination of different elements to form different compounds. These rules are what we call the laws of chemical combinations. There are 5 basic laws of chemical combination that governs the chemical combinations of elements.
We are going to study the laws of chemical combination, the 2 laws of chemical combination with a simple example. This is the example we are considering. Hydrogen combining with oxygen. 2 atoms of hydrogen combines with oxygen to form water. Okay, this is a chemical reaction. The first law that we are going to discuss is the law of conservation of mass. This law states that matter can neither be created nor be destroyed. And this law, it was proposed by Lavoisier. Okay, this law was proposed by the scientist Lavoisier, and he stated that matter can neither be created nor be destroyed. Okay, so this is the law of conservation of mass. Let's see what is this law. Okay, here hydrogen. Did you know what is the mass of hydrogen? Mass of one hydrogen atom is 1 gram, and for 2 hydrogen atoms it will be 1 plus 1, that is 2, and mass of one oxygen atom, it is 16. Okay, so here the 2 grams of hydrogen, it is comparing with 16 gram of oxygen to form water. Then what will be the mass of water? 2 plus 16, that is 18 gram. Right? Here 2 grams of hydrogen combined with 16 gram of oxygen to form 18 gram of water. Let's take the sum of masses of reactants. What is the sum of masses of reactants? It is 18. Right? Similarly, the mass of product, it is also 18. So, we got that the sum of masses of reactants, it is equal to the sum of masses of the products. Okay, that is how much mass we took in the reactant side, we will get the equal mass in the product side. The product obtained will be different, but still the masses of the reactants and the mass of the products will be equal. That is, here whatever matter we are taking to react, it is not destroyed, but it is converted into another form. That is the law of conservation of mass states. The matter, it can neither be destroyed nor be created. No new matter is formed. Only this matter is converted into a new substance. Okay, that is law of conservation of mass. Law of conservation, conserving the matter, it is conserving. It is not destroyed nor created. Hope you understood. This is the law of conservation of mass. And who is the scientist who proposed this law? It is Lavoisier. Okay, this is the law of conservation of mass. Then the second law of chemical combination, it is law of definite proportion. Okay, law of definite proportion. we are explaining this law of definite proportion with the same chemical equation. Okay, when we look at this, what is the formula of water? It is H2O, isn't it? Two atoms of hydrogen is combining with one oxygen atom, isn't it? And when we take the masses, what is it? 2 grams of hydrogen, it is combining with 16 gram of oxygen, isn't it? If you are taking the water from well, what will be the formula of water? It is H2O, isn't it? If you are taking this water from, we have collected the water from rain, still the formula of water, it is H2O, isn't it? And whatever be the source of this water, its formula is always H2O, and it contains two hydrogen atoms and one oxygen atoms, or its masses, it is always in the ratio 2:16. The ratio of the masses of hydrogen and oxygen will be 2:16, isn't it? This is the law of definite proportion. This law was proposed by Joseph Proust. The law of definite proportion states that a given compound always contains the same proportion of elements by weight. Okay, this is the law of definite proportion, or in other words, we can say that a given compound always contains same elements. Okay, a given compound always contains same elements in same proportion. Okay, that is the law of definite proportion. A given compound, here it is water, it will always contain same elements at same proportion. Okay, that is 2:1, hydrogen 2, oxygen 1. The given compound always contains same elements at same proportion. Okay, that is the law of definite proportion. Definite proportion. Their elements will be a definite, the elements have a definite proportion. Whatever be the source of the compound, it will always has a definite proportion. Okay, so these are the two laws of chemical combination. One is law of conservation of mass, and the next one is law of definite proportion. And the law of conservation of mass, it was proposed by Lavoisier, and the law of definite proportion, it was proposed by Joseph Proust.